Hi guys, in this video we are going to do the second question we have already followed with the first one. If you haven't watched that, please watch that before watching this video. I have given the link in the description. Also, if you are new to the Expectation Leader channel, don't forget to subscribe it. Okay, in the previous part of this video we have already discussed that how to consider when you are having a dam. If they ask the hydrostatic thrust per unit length of that dam, you need to figure it out the vertical component first of all you need to figure it out. After that, we have already figured it out in the last video. In this video we are going to figure the total resultant of that hydrostatic thrust per unit length from that dam. So when you are considering about that, we have already found the vertical component of this hydrostatic thrust. So here the next step is we are going to find the horizontal component of that hydrostatic thrust per unit length by that dam. When you are considering about the equilibrium of this water volume, we have discussed that there are only three forces, so that we can directly tell the weight would be equal to the vertical component of the hydrostatic thrust, and the horizontal component, which is made by the water from the left side of this water volume, is going to make a force on this rectangular area. So it's going to be equals to the dam's resultant, the dam's thrust, hydrostatic thrust force in the horizontal direction. So you can directly tell it's going to be equals to, let's say this is, if we make it like F, it's going to be equals to R, and let's say this is theta from the vertical, we can directly tell it's going to be sine theta, so it's going to be R sine theta. So we need to find what's the value of R sine theta. For that, we are going to find what's the value of this F. If we find that F, we can directly find the R sine theta. If we find the R sine theta, the horizontal component of the hydrostatic thrust, we have already found the vertical component of that hydrostatic thrust. From that, we can combine together and get the resultant hydrostatic thrust. So how we can going to find the F? So the simple thing is you can use an equation. So I'm going to write that. I hope you have already learned that. If there is a surface, simple surface inside a fluid, let's say this is a fluid. If you consider its area, what's the force acting on it? So that's the question. How we can figure it out, the force? That's very simple. You have an equation. The total pressure, let's say this is H, the height of this is H and the width of this is B. If we get an area, what's the force acting on this? If you cut down the area, and after that we are going to check what's the force on it. The force would be equal to the area into the total area into the pressure on the center of gravity of this area, so PT. So remember, if you are having an area, if you select an area in a fluid, in the same fluid, and let's say you knew that this is going to be the surface level, so if you consider an area over here, you can directly tell the force acting on this area would be equals to the area into the pressure of the center of gravity point. So actually we knew that if you take a rectangular area, the center of gravity on this area would be in the center of this rectangle, which means it's going to be in the h by 2. So if it's h, you can tell it's going to be h by 2. If we know this is h by 2, what's the pressure on it? We can directly find. If we knew that it's going to be the surface area, we are going to use the gauge pressure, so you can tell this is a 0 pressure on it, so it's going to be h by 2 rho g. The pressure on that center of gravitational point is going to be h by 2 rho g. Likewise, when you are considering about the area, the total area, when you are considering about the area, you are going to put the total area, it's going to be h into b. Actually, you don't need to remember this equation, but you need to remember this one. F is equals to a into rho g, a into pg. So the question is, we need to find the total F. It's going to be a into the, we need to figure out this area of this rectangle, because we are going to see what's the force acting on this area due to this water volume in the left side, pressure on that surface area. So we are going to figure it out what's the area of that, actually you can see that it's going to be a rectangular area. So you can directly write A into PG and it's going to be B into H. Actually we knew the height of this is going to be 50 and the length, the width would be 1 meter. We have already taken like that. So 50 into 1, and the pressure of in that center of gravitational point, actually we knew that it's going to be in the center of gravitation of that rectangle. It would be lies on the center. It's going to be, if it's 50, it's going to be 25. So the pressure on that point is going to be 25 h rho g, 25 into 10 to the power cube into 9.81. So I'm going to write it like this: 25 10 to the power cube into 9.81. So this is the horizontal component. But another main thing is I have already mentioned that in this video we are going to find the total resultant component of that hydrostatic thrust per unit length of that dam, and we are going to check where is that point exactly, where these three forces are going to be acting. So here actually we found that the force of the resultant force, the hydrostatic thrust force in an area, if you take inside a fluid, is going to be like this. So the next question is whether this force will be acting on this center of gravitational field. Actually that's not, because actually knew that in this point we are going to take the static pressure as 0, because we are going to take the atmospheric pressure as 0. When you are considering about the gauge pressure, it's going to be 0, and in the least side, in the last position, it's going to be h rho g. Because of the height of h, it's going to be h rho g, so it's going to gradually increasing. So we can tell that the total force would be in the middle center. So how to find that? There's another equation to find that point. Let's say this is center of YC. It's going to be equal to YG, the center of gravitational Y. Let's say this is going to be the h by 2 would be the YG, the vertical height from the vertical depth from the free surface to that center of gravitational point. It's going plus, and we need to consider something. It's going to be I over, what's meant by the I is we need to find the second moment of area divided by area into YG squared. So that's the equation. So you need to remember that this is very simple equation. How to find this height? You can find the second moment of area with with many axes, but here we are going to take this part. We are going to take the second moment of area through its center of gravitational point, and we need to find the I, the second moment of area of this part, and divided by the total area, and YG we have already know the depth from the free surface to up to this center of gravitational point. So you need to figure it out and get the answer, which means it will going to get, actually we knew that there's the force, it's going to be 0, and there's another force very big, and we are going to find the resultant force. We knew the magnitude of that. We are going to find the length, the depth which is acting on that. So let's say this is going to be the YC. But the thing is, if you have a rectangular area, you don't need to remember that. But the thing is, when you have any other areas, you need to remember like this part. You need to use this part. But if there is a rectangular part and it's from the free surface, you can directly use one equation. It's going to be the YC would be actually we knew that the force on this point is going to gradually increasing, which means it's like a triangle. So the triangle means we can tell the total force of that triangle would be in the center of gravitation of that triangle, which means it's going to be in the 2 by 3h. If it's h, we can tell it's going to be 2 by 3h, like a triangle. You can directly use that. If it's a rectangular area, if we consider the force of that rectangular area, so it's going to be like this. If you don't know, if you have any other unknown elements or unknown shapes and unknown areas, you need to use this equation, otherwise it will be difficult to find that. I hope you have now clearly understood, but in up to now you don't need that where it's going to act, but in the last question you need that. So when you are considering about that, we need to figure it out the r sine theta, the horizontal component of the hydrostatic thrust per hydrostatic thrust. So I'm going to use this calculator. 50 into 25 into 9.81, which is going to return 12,262.5 kilonewton. But we need to find the hydrostatic thrust per unit length, so we need to divide it by 1 meter, because we have already taken for this 1 meter length, we have found this answer. But the question is, we need to find the resultant of these two. Actually, we knew the vertical component over here and the horizontal component over here. We can directly write it like this: r would be equals to root of r sine theta whole thing squared plus r cos theta whole thing squared. If you do so, we can use this calculator again. Root of r sine theta, actually the answer we have already get for that, squared, plus r cos theta, we have already found that 4087.5 squared. Yes, it's going to return 12,925.8 kilonewtons. So now we have figured out the answer, 12,925.8 kilonewton. But it's not finished. We need to find where is the resultant force, where is this force is acting on it, where in this time where is this force acting on it. But the thing is, they have given some details about, so we need to use that to figure it out the answer. Actually, we knew that when you are considering about the water volume of this parabolic segment, they have already mentioned it's going to be in the 4.68 meter horizontal from O, which means from this O point, if I'm going to draw another side again, let's draw like this. If you consider this part, we actually knew that it's going to be lies, the center of gravitational point is going to be in this 4.68 meter, which means it's going to be in this direction. So let's mark it like this. It's going to be in this side. This is going to be the weight. So the next part is, actually we knew that where is this force acting on it. We have found an equation. You can directly use this, but if you like, you can check your answer whether it's going to be 2 by 3 h by using this equation, but I'm not going to do that now. If you want, you please try that. So I'm going to mark that 2 by 3 h directly, which means it's going to be in this side. Actually, we knew that the total h is going to be 50 meter. So 2 by 3, which means 16.67 into 3, I think 50 divided by 3 into 2 is going to be returning. This is going to be 33.33, which means it's going to be 16.67. Okay, now we can figure it out. Actually, we knew that if there are 3 forces and an object is in the equilibrium position, we can tell the third force would be go inside this path, inside that point. So that's the main thing. So now we have figured it out. It's going to be inside this fourth. From that we can tell it's going to be in this point, and we have now figured out this part. So if you want, you can tell where this force cut down this OP. You can easily figure it out. Let's try that. You need to figure it out where this OP cut down, where this force cut down this OP. So we can figure it out where this force acting on it. Please pause the video and try it in your own very simple geometry. I hope you have already tried that. When you are considering about that, you need to find where is this, what's the value of this theta, because actually we knew that this is 4.68. So we need to find this length to find the total length from O to the cutting point. So we need to find this part here now. But here actually we knew that this is going to be 16.67. Using the trigonometric functions, we can tell it's going to be 16.67 divided by the tan theta. So we need to figure it out what's the tan theta right now. Actually we knew that the tan theta would be equal to we knew the vertical component and the horizontal component. So it's going to be equals to vertical component 4087.5 divided by its horizontal component tan theta. If you draw a triangle, you can easily figure it out. It's going to be 12,925.8. So now we can figure it out the tan theta. Let's mark it like this: 4087.5 divided by 12,925.8, which is going to return 0.316 Okay, it's enough. Okay, so after that we need to figure it out. This length, let mark like x going to be equals to, when you consider that, if you consider this triangle, it's going to be 16.6, x tan theta would be equal to 16.67, so that you can tell it's going to be equal to, x would be equal to 16.67 divided by tan theta. Actually we knew the value for 0.316, so I'm going to use the calculator and get the answer. 16.67 divided by the previous answer we got, it's going to be 52.71072 meter. So the thing is, if you get this point from the O, you need to add this 4.682. So 52.72 plus 4.68, you are going to get the answer now. So if you do so, you are going to get 52.71 plus 4.68, you are going to get 57.39. Hope you have got the answer. If you have any doubt, please comment it below. I hope you have clearly understood that. Also, if you haven't subscribed our Expert Tutor channel yet, please do it fast. Thank you.